Hey guys, just going to do a quick reference for you for exponential growth and decay and this geometric sequencing we did today. I'm going to give you the formulas again and walk through each of them step by step so you have a reference to have at home. So, let's talk about exponential growth and decay. Remember, growth is when you are having an increase. Decay is when you're having a decrease going on. So our formula that we're going to be using is y equals a times b to the x, where a is our initial amount, so like what you pay to start with. Your b is your base. This is probably going to be a decimal of some sort. And then, of course, x is going to be your exponent. So when we have our growth or our increase, our base was probably, let's put probably instead, going to be less than 1 because, or it's going to be greater than 1 because, like if we have a 14% increase, then you're going to do 1 plus that percent is the decimal, which is 1 plus 0.14, which gives me 1.14. And that then becomes my base. Okay? All right. When we have a decrease or a decay, our base is going to be less than 1. You're going to do the same thing if I have a 16% decrease, then I'm going to do 1 minus that as a decimal, which is minus 0.16, which would give me 0.84. Again, that would become my base. Okay, all I have to do then, let's say the problem tells me, change colors for us. Okay, let's say the problem tells me that we have a 9% increase after I paid $200 down. Okay, all right, so this becomes my initial value, which is my A, times my base becomes this plus 1, 1.09, and I don't know my X yet. Okay, I can figure that out though. Okay, so what if I want to know how much money will I have after 5 years? That becomes my X and it becomes 5. Okay, then all you have to do is plug this in 1.09 to the 5th and then multiply it by 200, which I don't have a calculator. You get 1.09 to the 5th should give you 1.538, big long line of numbers, times 200. And I just want to know about, since I'm dealing with money, so you would get 307.72 cents. Okay, so this is going to show you like how much growth am I going to have after I leave so much money in the bank. Okay, these are your real life applications of these exponents. Okay. All right, so there's an example of that. Let's go to compound interest. I know this is a variety of things, but your big thing is let me plug in the numbers. Okay, let me plug in what they give me. Okay, so let's talk about if I am going to the store or to the bank, let's say the bank, and I have put down $500 in the bank. I've paid $500. Okay, there's an interest rate on my account of 5%. So my interest rate is 5%. Okay, and they compound this, let's say biannually. Remember, bi will be 2. Okay, 2. And I want to know how much money I will have in 20 years. So all I have to do is plug in my numbers. So my balance is what I want to know, so I still don't know that one. My principal is my initial deposit. How much did I put down first? Okay. My 1 I can't change. That's going to stay the same. What is my interest rate? I want that as a decimal. Okay, so 5% as a decimal is 0.05 divided by how many times is it compounded per year, which is biannually, so 2. And then I have my n times 2, so we got 2 again, times how many years, times 20. Okay, you can go ahead and take care of this, and 2 times 20 will give me 40. Okay, then let's work what's on the inside. 0.05 divided by 2 should give you 0.025. So if we leave our 500 and then plus the 1.025 to the 40th power. Okay, so we combine this. Now let's take it to the 40th power. You're going to get a really large number, or a really small number actually. So go ahead in your calculator, multiply that by 500. You're still going to get a really small number. What you get is 4.14 if you times 10 to the negative 62. So a very small number. Okay, and then so how much interest am I going to collect? Not very much. Okay, so that's a made-up problem, so you're going to have some that look a lot better than that one. Alright, so then we go into geometric sequencing. Okay, remember this is proceeding at a constant rate by multiplying or dividing. So it's something like, okay, we have 5, and then we multiply it by 3, so we get 15. Multiply that by 3, we get 45. Multiply that by 3, and it's going to continue on. So I multiply by 3, multiply by 3. So it is a constant value, but we're multiplying. So remember, linear was when we had like 2, 4, 6. We were going up constantly, but we were just adding to. Okay, so now the key is multiplying or dividing. Okay, so we have to look at these sequencing. Is it a geometric sequencing or not? Okay, the key here is it geometric, which means it goes up by multiples. Okay, so we got to look at this. We got a 5, -5, 5, -5. Does it go up geometrically? It does, because look, I can multiply by -1, multiply by -1, multiply by -1. Okay, and then I get 5 times -1 is -5. -5 times -1 is 5. So is this a geometric sequence? Yes. Okay, then I have the sequence 1, 2, 3, 4. Okay, can I multiply to get to 2? Can I multiply to get to 3? I end up adding 1 each time. So is this geometric? No, but it is a linear. Okay, so don't get those two confused. Linear would go up by addition or subtraction. Geometric goes up by multiplying or dividing. Okay, all right, you got two. We're given two formulas with that. You get the recursive and the explicit formula. We're going to deal with both of those. Okay, so we were given the recursive formula, which was a to the n equals a n minus 1 times r. Okay, so with this, remember, A1 is our initial condition, which really is your starting number. Okay, so think about your starting place. And then our R is our ratio. Remember, our ratio is really like 21 divided by 7, which should give you 3. So what is it? Okay, what is it? It's what you multiply by to get to the next number. Okay. Alright, so all I have to do now is plug my ratio in and my A1. But notice we don't have an A1 in this formula. Okay, so we get A to the n equals A to the n minus 1. We can't do anything with that. Times my ratio, which is 3, and then I'm done. Okay. Alright, you can work with these later, which I'll show you tomorrow, where if I want to know like the 7th term, that's my n, and I'll show you how to do all that tomorrow. Okay, so that's the recursive, using this formula. My explicit is using this formula. Notice we have an equals a1 times r to the n minus 1. We're going to use the same set of numbers. So my an stays the same because we can't fill that in yet. So a1, what is my starting number? It happens to be 7. And then my ratio was 3. And then my n minus 1 I can't do anything with yet. Okay, so this can be changed to a function. Remember, what we need to do is plug in our numbers. Okay, it can be changed to a function if we have more information. Your n would become like your x, and this would be like your y. You would plug it in, and then you can make your chart like we have before, and then we could graph it, and it should take the same shape as the rest of them, which is the point of that. All right, so hopefully this helps you in your homework. Remember, we're doing all on both sides. Okay, we're going to continue on. We'll wrap this up. We have a short class tomorrow. We'll wrap it up, and then we will go on. We're going to polynomials, which is so fun. So I will see you tomorrow. Have a good evening.